Hello, everybody. How's it going? I see more people's faces than I usually do. This is kind of exciting for me. Uh, so we're gonna do something. Hopefully, I will be able to do it for you here. I've never tried it. I've never tried this before. So please, be a little bit patient with me. Oh, there's Neha. Be a little bit patient with me here as I try to get this accomplished. But I'm going to be dissecting this sheep brain. I'm going to try to do it underneath the camera that I have set up right here. My setup, I got the iPad on a stand. I've got the sheep brain underneath it. So I'm going to kind of be doing it without looking directly at it because I'm trying to do it under the camera, make sure you guys can see it. Let's see who just joined us. So Neha's here. Okay. So I posted, there's Lexi. All right. I posted the dissection manual for you guys. So we're going to run through that. There's a couple things I probably am going to skip. I might not go in the exact same order as what's posted on Schoology. Did I not? I probably, in all my excitement of getting everything else ready to go. Let's see if I need to hit publish on that. And then Abby, you can use your scissors to cut that out of the bag. There you go. And I've got it projected up here so that you can kind of follow along, Abby, as I go through and do it so you can see it too, since I can't get within 6 feet of you for an extended period of time. Okay. All right, so it looks like you should see the brain, yep, you should see it. So today's page, you should see the Carolina Mammal Brain Dissection Guide. That's gonna kind of run through the steps, the brain picture instructions. What you're gonna need to do is you are going to need to find and take pictures, and probably you're gonna end up taking screenshots of the different parts of the brain as I go through and dissect them, and then you're going to be labeling those screenshots. Okay? Does that make sense? All right, and you're going to label the parts as we go through them here. All right, so you guys think we're ready? Question is, am I ready? Okay, here we go. You can hear me okay, right? Everybody hear me okay? Yeah? All right, I'm going to stop the video. I'm going to stop this video just so that all you see is the brain video here. So there we go. There's my hands. All right. So there we go. This is the brain right here. And as we look at it, there you can kind of see there's this coating around it. Okay. That coating is the dura mater, and we have to remove it. Okay. And the best way to do that is to use my scissors to remove it. I think you can see best right here, the cerebellum back here, and here's the spinal cord coming out. It's covered right here with this, with the dura mater, with that connective tissue here. Okay. By the way, you might notice one thing here: the spinal cord for this brain goes straight back, right? Straight back. Whereas our spinal cord goes down, right? Why does the sheep spinal cord go straight back from the brain? Why does it go straight back instead of coming down here like ours does?
Because they're on all fours.
Because they're on all fours. Yeah, exactly. Thank you, Crystal. They're on all fours. So their spinal cord has to go out horizontally since they're on all fours. All right, good. So here's what I'm going to do. I'm going to take my scissors, and with the pointy side, because your scissors should have a pointy side and a dull side. Okay, with the pointy side, I'm going to start back here, and I'm going to try and cut up towards the front, kind of right down the longitudinal fissure as best I can. I might have to go off to the side a little bit because there's a thick piece of connective tissue there, and I want to aim the point of my scissors up so that I don't damage the cerebrum as I do that. So now you can see the dura mater coming off. Can you guys see that? Kind of cool, right? Okay, so I just need to work to get this removed. It can take a quick minute here to get it all off, because then what we want to do is look at some of the external features of the brain as we do this. Okay, so let me, oh, it's sort of stuck together. All right. We're going to continue cutting this off as I go around. There's no real rhyme or reason to it. We just need to get it off of there. The one thing I want to try to protect on the underside here, let me get it back underneath there. Towards the front of the brain, I've got this little bulb right here. That's the olfactory bulb. So I'm going to try to not have that get ripped off when I take off the dura mater here. All right, so I'm going to just keep cutting this off. Try not to damage any of the structures on the brain here as I do it. All right, so now I'm going to work towards the other side of the brain. Doing my best to keep it underneath the camera also. All right. I did manage to keep the olfactory bulbs intact. All right, I'm getting there. Abby, how are you doing back there? Okay. Now you'll notice that between the cerebrum, Abby, and the cerebellum, it goes down pretty deep between them. You can leave that in there. Okay. Looks like I'm almost done getting this off. I just got another couple. Sorry, guys. All right. So there we have it. I removed the dura mater from the cerebrum. You can see here's the cerebellum, and the dura mater really goes down deep into this fissure between the cerebrum and the cerebellum. And I'm afraid I might damage some structures if I try to rip that out of there. So I'm going to leave it in there, make sure I can see everything else I need to. I can. Okay. On the underside, looks like I got just a little bit more that I want to try and remove if I can, but I don't want to do too much there. Okay, now on the underside, down here, I have here the brain stem where it's swollen right here. This is all brain stem. And then where that swelling stops, and I just have this sticking out in the back, this is the spinal cord. So this is brain stem here, where I've got this swelling. This is spinal cord. This is my cerebrum with all my different lobes that I've got, right? Okay, so I'm going to have the frontal lobe up here, right? I'm going to have the parietal lobe back here, occipital lobe in the very back, and temporal lobe down here on the side, right? So frontal, parietal, occipital, temporal. You guys seeing that okay? Okay. Frontal. And right here is kind of where that dividing line is. Parietal, occipital in the back of the brain. Okay. Right there. And temporal here. So occipital towards the back. Okay. All right. Now, trying to see if there's any other structures on the outside that I can find to show you. I want to remove this right here. Cut this off. Because there is one other structure that I do want to show you. On the underside, okay, so now I'm on the bottom of the brain. Let me see if I can find the best way to. All right. So now I'm on the bottom of the brain. And right here, at the very front, those are the olfactory bulbs right here. Let me see if I can. Here and there, those are the olfactory bulbs. This structure right here, it's covered in dura mater. This would be the optic nerve. The eyeballs would sit right up here, connected to the optic nerve. This is the optic chiasma, where the information coming down this optic nerve crosses over and heads to the occipital lobe on the opposite lobe of the brain. And this would be where the other optic nerve would come out, right? And then cross over here at the optic chiasma to go to the occipital lobe with information on the opposite side of the brain there too. Okay, so Abby, how are you? Okay, did you get the dura mater off? Did you find the structures I was just talking about? Yeah. Okay. All right, so now what I'm going to do is I'm going to make a mid-sagittal cut right through the longitudinal fissure all the way to the back. Oh, before I do that, I do want to show you a couple of structures. I'm going to pull down the cerebrum and the cerebellum, okay? Or I'm sorry, I'm going to pull down the cerebellum and the brainstem. So I'm looking at the back and deep underneath the cerebrum. And you should see a structure right here, okay, resting on top of what looks like a shelf. This kind of looks like a butt sitting on top of a shelf here, okay? This structure right here is called the superior colliculus. And this is the inferior colliculus. These are involved in vision. Okay, that's all you really need to know there. And you see that little button sitting on top of the superior colliculus right there? Let me see if you see that little button sitting on top of the superior colliculus? You see it or no? Yeah, okay. That little button sitting on top of the superior colliculus, that is the pineal gland. Okay, that is the pineal gland. And if you remember, we learned that the pineal gland makes a particular hormone. Do you remember what hormone that is?
Melatonin.
Melatonin, yeah. Melatonin is what that one makes. So it helps us sleep, right? Okay, so I'm going to take my scalpel. I'm going to make this incision, this sagittal incision, right down the middle. Okay. And right through the cerebellum and the brainstem and the spinal cord. And hopefully I did a semi-decent job so that we can see everything okay. So there we go. I'm just going to remove the rest of the, I'm just removing the rest of the dura mater here now that I've got it cut open. Making sure that I'm not, there we go. Okay, so here we got the inside of the brain, okay? And so there's just a few structures that we're gonna work to identify here, okay? A few structures we're gonna work to identify. And let me take a look at the two hemispheres I got here. Okay, so this is the one I wanna use. All right. So a few things to identify, right? First of all, I've got this little chamber right here, okay, in the front of the brain. This little chamber is a cavity where cerebrospinal fluid circulates. It's called the lateral ventricle. Hang on, let me turn this. Bring it up here. There we go. There we go. Okay. So this is the lateral ventricle right here where cerebrospinal fluid circulates. Right here, this structure right here, sitting above the lateral ventricle, is the corpus callosum, right? And we talked about the corpus callosum. Let's see if I can bring it a little closer here. This is as close as I can bring it. We talked about this corpus callosum that sits right here. What does the corpus callosum allow for? You guys remember?
Communication between the two hemispheres.
Yeah, communication between the two hemispheres, right? Okay, exactly. Exactly. All right. Now, so this was the lateral ventricle, right? There's one on each side, right? And these are actually ventricles 1 and 2. There are 4 ventricles in the brain where cerebrospinal fluid circulates. The lateral ventricles, 1 on each side, count as ventricles 1 and 2. And then right here, this is where the third ventricle sits above this circular structure right here. This circular structure right here is the thalamus. Okay, so here's our thalamus. And right here, inferior and slightly anterior to the thalamus is the hypothalamus. Okay, and then the pituitary gland would sit down here. So thalamus, hypothalamus, third ventricle right there. Okay, now a couple other structures here. All right, we're going to work our way up. Down here is the spinal cord. Okay, and in the spinal cord, there is a canal called the central canal where cerebrospinal fluid circulates. Then we see this bulge right here. Okay, this bulge right here is the first part of the brain stem. This bulge right here is the medulla oblongata. You guys remember what the medulla oblongata does? Breathing and heart rate. Very good, Abby. Thank you. And then here, this second bulge right here is the pons. Okay, so we got the pons, where this bulge right here is located. We got the medulla right here, and then the spinal cord after that. Okay, and then the midbrain is going to be right in here. Okay, so the parts of the brainstem: midbrain, pons, medulla, spinal cord with its central canal. Okay, now remember I said there are 4 ventricles. The 4th ventricle lies just inferior to the cerebellum, back here. What's the cerebellum responsible for? Anybody want to give it a
Balance
shot?
and coordination.
Balance and coordination, right? Yes, balance and coordination. And you can see the white matter inside of the cerebellum. It kind of looks like a tree, right? The way it's all branched like that, okay? The fancy name, and you'll see it in your lab, the fancy name for that white matter with that pattern in the cerebellum, let me turn it there, it's called the arbor vitae. Arbor vitae. Vitae is Latin for life. And arbor, if you're familiar with Arbor Day, what are you supposed to do on Arbor Day? Anybody know? Anybody ever heard of Arbor Day? Nobody's ever heard of Arbor. What are they teaching in elementary school these days? I swear. On Arbor Day, you're supposed to plant a tree. Okay, Arbor Day is for trees. So this is literally translated arbor vitae is tree of life. Okay, that's found there in the cerebellum. All right, so I'm just trying to make sure that you saw these okay before. All right, but if I'm looking at the brain here, frontal lobe, parietal lobe, occipital lobe towards occipital lobe. Here, let's go this way. Occipital lobe towards the back here, and then temporal lobe here on the side, right? So frontal, parietal, occipital, temporal. And I think now you can see a little better on the underside of the brain. Let's see if I can get the other half here. Okay. Sorry, just grabbing my tool. Okay, on the underside of the brain, see the structure that makes an X here, and it kind of, the nerve got cut off over here. But see that structure that makes the X right there? You see it? Yeah, that's the optic chiasma. Anybody know what the Greek letter chi it looks like? The Greek letter chi? Anybody? I was in the Theta Chi fraternity when I was in college. The Greek letter chi is the letter X. Looks like the letter X, which makes sense because this structure where these two, where the optic nerves cross and information gets passed to the occipital lobe on the opposite hemisphere from the eyeball, kind of looks like an X, right? So that's the optic chiasma. All right, and then we can see the brainstem back here. Remember, we had two swellings, right? You had the pons, and then you had the medulla. Medulla, pons, okay? Does anybody need me to go back to any structures? The one thing we're going to skip because it never seems to work, we are going to skip the part that says find the hippocampus. I think it was step 16 in the procedure. We're going to skip that, okay? And so looking at the brain here, again, you can see, where did my tool go? You can see spinal cord, cerebellum, cerebral hemispheres. Longitudinal fissure running right down the middle between them, right? Okay. And then you can't really see it anymore because I cut it. Okay. All right. I do believe those were all the parts of the brain that I needed to show you. The four ventricles, the corpus callosum, the thalamus and hypothalamus, the midbrain, pons and medulla, the spinal cord, the central canal, the cerebellum and the arbor vitae, the lobes of the lobes of the cerebral hemispheres, and the optic chiasma. Kind of going through a checklist in my head. Is there anything, if you guys open up that brain picture instructions document, check it and see if there's anything on there that I did not show you.
Can you go back to the olfactory bulb?
The olfactory bulbs, yes. So if I trying to get it as close as I can to my iPad without actually touching my iPad with the brain. Okay, so the olfactory bulbs sit right here on the inferior surface of the cerebral hemispheres, right underneath the frontal lobe, here and here.
Thank you.
You're welcome.
Could you do the sulci and
The sulci and the gyri?
Yeah.
Yeah, okay. So the sulci are going to be the grooves, right? And the gyri are going to be the bumps. Let's see if I can. Right. So any grooves in the brain are sulci. Any bumps are gyri. And the purpose of having those, right, is to allow for the brain to fit into, for more surface area so that the brain can fit into the cranial cavity, okay? All right, any other questions? Anything else?
Can you
from
show
that?
us the third ventricle?
What's that?
Third ventricle.
Third ventricle. Sir. Third ventricle sits, let's see, I think it might show better on this. Oh, okay. Third ventricle sits right above the thalamus, right here. So here's the thalamus, this circular structure right here. Third ventricle sits right above it. Just trying to bring this where you can see it better. Tilt it the right way. Okay. So thalamus, third ventricle. Here's the lateral ventricle right there. Okay, anything else? All right, yeah, if I could send the brains home with dissecting tools, I would, but the school frowns on that. So, so sorry, I couldn't have you guys do this one at home. All right, any other questions for me?
Wait, between the corpus callosum and the lateral ventricle. I know you just showed the lateral ventricle, but can you just do it again?
Yeah,
please?
oh, we're good. Okay, so this is the lateral ventricle here, corpus callosum right here. See that white line running right here?
Yeah.
That's the corpus callosum. And then this opening right here is the lateral ventricle. And there's one in each hemisphere. And those count as the first two ventricles, ventricles 1 and 2. That's why all of a sudden we go from lateral ventricles to the third ventricle, is because the two lateral ventricles count as ventricles 1 and 2.
Okay, cool. Thank you.
Yep. All right. Any other parts of the brain you wanted to see again, or needed to see again? Okay. All right. So here's what I want you guys to do. I want you guys to start labeling any pictures that you might have taken, because Abby and I need to clean up our mess here a little bit. So that's going to take me like 2 minutes. I'm going to drop these tools in some bleach, and I'm going to throw out the brain. And so Abby, yeah, your brain can go, did you take some pictures? Okay. Yeah, why don't you take a couple pictures, and then your brain can go in the garbage and your tools go in the bleach, and that'll be that. So give me 2 seconds to clean up here, and then we